All right, so the second part of this lesson, essentially just looking at a few more involved examples and a few more steps. But if I look at this first one here, a bit more stuff going on here. And so I have a monomial times a binomial, and then another example of this all put together. So like before, though, I would distribute, and I'm going to distribute the 3 here. So I have 3 times 5a, which is 15a. And then I want to think about 3 times minus b, which is negative 3b. Now again, if I'm saying that a little too quickly, just keep in mind I'm speeding things up a bit because we've seen these sort of steps in previous videos, so I'm hoping that we can become a bit more proficient with it. But again, just each of those last couple steps is part of the lesson on multiplying a monomial by monomial. So I'm definitely getting a bit faster with this. So that's that step right here. Over here, I have 2 ways of looking at it. What I highly recommend is think of this as minus b times everything inside the brackets. Another option, which I don't recommend, is think of it as just b times everything inside the brackets, and then subtract everything that's left. I don't recommend that because it's more work, and there's a really good chance you'll mess up a sign somewhere. So over here, just same idea. Just think of it as negative b, or negative 1b if you'd rather. Just like right here, this positive 3 in the front. I could put a plus sign in the front. Doesn't make a difference. So in this case, I now have negative 1b times 5a. Well, negative 1 times 5 is negative 5. A times b is just ab. And then right here, I have negative 1 times, well, negative 1b times negative 2. Negative 1 times negative 2 is positive 2. And there's nothing, just a b times nothing else. And so this represents the second part. Now I should see if there's any like terms, and there are. If you look right here, I have 15a and a 2b. So those are like terms, so I should combine those together. And the order I write these doesn't really matter. I'll put my 15a and 2b together, so that's 17a. But if you look at the terms that are left, they're not like terms with one another, so I'll just write them down the same order, have them above. Minus 3b minus 5ab. All right, so here, same idea, just my coefficients that I'm multiplying by in the beginning are not whole numbers. That's really the only difference between these two questions if I zoom out a bit. I had a 3 in the first one right here. Now I got 1/2. But same idea. So I'm going to distribute the 1/2, which is actually pretty nice to do because multiplying by a half, is the same as dividing by 2, the same as finding half of a number. So 1/2 times 6x. It's really just 1/2 times 6 I need to think about. 1/2 times 6 is the same as half of 6, which is 3. And then x times nothing else, so just that. So 1/2 times 6x is 3x. And then I have 1/2 times negative 8, which is another way of thinking about that is half of negative 8. And half of negative 8 is negative 4. There's the first part done. Now looking at this. And again, I recommend thinking of it as negative 1/4 times each of these terms. So first, negative 1/4 times 8 is going to be a negative number. A quarter of 8, 1/4 times 8 is the same as 1/4 of 8, or 8 divided by 4. Right, 1/4 of 8, or 1/4 times 8, it's all the same thing, which is 2, a quarter of 8. And so 1/4 times 8 is 2. So negative 1/4 times 8x is negative 2x. And then almost done. I have negative 1/4 times negative 12. Well, negative times a negative is a positive. And a quarter times 12 means what is 1/4 of 12? What is 12 divided by 4? Which is 3. Now, like before, I should see if there's any like terms, and there are. I have a 3x and a minus 2x, which I can put together. So 3x minus 2x is just 1x. I also have a couple of constants here. I have negative 4 and positive 3. Put those together as negative 1. So in the end, everything you see here simplifies down to just x minus 1. Right, so the last example. Just got a few more fractions, but still decently nice fractions. And so first, let's think about 2/3 x times 3x. Well, let's really first think about 2/3 times 3. 2/3 times 3, you may be able to see what it is, but it may be helpful to think of it as like 2/3 times 3 like this. And now these fractions are getting a bit more involved. And you can use a calculator if you want. That's it in the end. So remember, when you're multiplying fractions by whole numbers, it's really just 2 times 3, which is 6. 3 times 1 is 3, 2 whole. Or maybe you can see right away that these 3's are going to cancel out. Either way, 2/3 of 3 is 2. You can just visualize the number 3 and 2/3 of it. Either way, that's 2. And I have x times x, so x squared. Why did my marker get so big there? All right, and then 2/3 x times minus 6. So what is 2/3 times 6? I know it's, or negative 6. I know it's going to be a negative number here. And again, you can use a calculator. You may just be able to see what 2/3 of 6 is. For example, right here, I can see if I just multiply it out, I get 12 over 3, which is 4 whole. Or I could reduce this down to 2 over 1 and get 4. Again, these are all things we've spoken about earlier on in the course. It's really a review of previous math courses. Or you can use a calculator. 2/3 times 6 is 4. So 2/3 x times negative 6 is negative 4x. All right. And then right here, negative 3/4 x times 8x. I know it's going to be a negative value. 3/4 of 8. I could work it out again. 3/4 times 8. So if I do that, I get 24 over 4, which is 6 whole. X times x is x squared. There's that first part done. And lastly, negative 3/4 times positive 2. Well, it's going to be a negative number. 3/4 of 2 is 1.5. Or 3 over 2, or 1.5. But I'll stick with 1.5. And again, without a calculator, 3/4 times 2. I get 3 times 2 is 6. 4 times 1 is 4. 3 over 2. And so I have here just negative 1.5x. And now, like before, just see if there's any like terms. And there are 2x squared minus 6x squared. Those are like terms. 2 take away 6 is negative 4, so negative 4x squared. And right here, I have minus 4x minus 1.5x. It's even more negative. It's negative 5.5x. And so keep in mind, the only differences about this question compared to the very first ones from the previous lesson is just the numbers are a bit messier and a few more steps. So it's a bit more difficult in terms of the number of steps, but it's the same idea all the time.